Yeah, we'll proceed. Sorry for the disturbance caused. Now we'll proceed. Right. So the IP version 4 is already running out of address. That is why the reason we go for IP version 6. And there are some solutions for the exhaustion of IP version 4, like network address translation. But even though we have the network address translation, it you will be discussing about network address translation and the networking layer. Then we discuss about the network layer. Solutions like NAT can never be a long time solution because they introduce latency in the network. And with the growth of IoT devices, now you could see that almost every small devices possess an IP address. Your smart glass, your smart watches, your smart projectors, smart water bottles, smart car, everything demands an IP address. So in order to accommodate all those things, we go for IP version 6. Now, already the traditional networking devices are running on IP version 4. So how are we going to manage this coexistence? So the traditional routers, switches, everything is running on the IP version 4 networking. So when we introduce IP version 6, is there really a possibility of coexistence is what that question arises. But there are some three categories of migration techniques available. One is the dual stack. So dual stack is nothing but the device runs both the IP version 4 and IP version 6. So every device that manages the internet runs IP version 4 and IP version 6. The second one is called as the tunneling. So tunneling is nothing but you have both the devices. Okay, so let me just explain the tunneling with the help of one example. So you might have already seen those people in Kerala. You might have already seen you will have some land space. Okay, so this is called the land space. Then you will have backwaters, and then again you will have the next land space. All right. So in that case, you want to move from a car from this location to this land space. What do? You will come in a car till this land space. Then when you want to cross it, you will use a boat, right? So you will use a boat and you will make the car to sit on the boat. Then the boat will take you through the water space and then take you to the destination in the land space. So similar to that of we are following in the tunneling. So in the tunneling, we'll have something called IP version 4 network. So here is again an IP version 4 network, or let me say this is version 6 network and this is version 6 network. And in between it encounter a version 4 network. All right. So now this version 6 packet, so imagine this is a version 6 packet. It is tunneled, okay, through an IP version 4. So maybe you imagine this as a boat, and I'm going to make this packet to sit over the boat of IP version 4. And or you have a version 6 packet which is wrapped by means of a version 4 packet, and then it moves to the next part of the network. So this is how the tunneling works. And translation is something similar to that of your network address translation. So when it comes here you have a device which runs a dual stack. So version 6, when it comes to this location, it is translated to version 4. Okay, and then again here you have a routing device, so it is translated to version 6. So this is the method, or this is a few methods, three methods: dual stack, tunneling, and translation, which is used for the version 6 and version 4 coexistence. Now moving on to the next concept. So how are the IP version 6 address represented? So you know IP version 6 is 128-bit long. It is a very vast address. So if you see here, it is 128 bits in length, all right? And it is not case sensitive. For example, I can even write EF uh, AB. This can even be a representation of an IP version 4 address, a version 6 address, right? So it is not case sensitive. And the format is, it is represented by means of hextet. Okay, hextet, Hextet. So you will have 1, 2, 3, 4, 5, 6, 7, and 8 sections. You will have 8 sections, and every 8 sections is represented by means of 4 digits. Okay, so I think the next slides, all right. Right. So every section, okay, every X is represented by means of 4 digits, and every digit is represented by means of 4 binary bits. For example, 2 means you can write it as 0, 0, 1, 0. Okay. And 0 zeros are represented 0, 0, 0, 0. Again, that is represented 0, 0, 0, 0. And 1 is represented 0, 0, 0, 1. So this is what the representation of 2001. Okay. So this is the IP version 6 representation. Okay. And every digit, you have 8 sections. Every section is represented by 4 digit, and every digit is represented by a 4-bit binary number. All right. So now this is a very big representation. How can you shrink it is what the question. Okay. So how can you make it a little bit easier for representation is there are two rules for IP version 6. Two easy rules for IP version 6. Rule number 1 is you omit the leading zeros. Example, here you see 01AB can be written as 1AB. Okay. Similarly, 09F0, you can write it as 9F0. All right. So because I'm just omitting only the leading zeros. You are not supposed to omit the tail zero. All right. So 0A00, you can write it as A00. All right. So if suppose you could see in the example below, 2001 0db8. So here I omit this 0. Similarly, here I just take all those 4 zeros and I am writing it as single 0. Similarly, here all ones and all these zeros represented as a single 0. Again, all these zeros represented as single zeros. And in the last case, in this case, it is 0200. So I just mentioned as only 200. All right. So this is how you can mention the easy representation of an IP version 6. All right, it is a easy representation of IP version 6. This is rule number 1. You take the leading zeros. Now the next rule number 2 is any one part of your IP version 6, continuous zeros can be represented by double colon. So here if you use this, okay, if this in the first, this example, if you write it in the first format, you will get 2001 colon DB8 colon 0 colon 1111 colon 0 colon 0 colon 0 colon 200 is what the first rule. When I apply the first rule, this is the answer. Now I get continuous zeros here. All right, I get continuous zeros here. So I just replace all these continuous zeros with a double colon. So that is what is written here. So 2001 DB80 1111 and the double colon comes here. So any part anywhere else in your network, you can use this double colon. So let me give you some examples. You can just solve it. All right. You can replace the IP address with the double colon. So I'll give you some examples. You can give the answer in the chat box. Okay. So the examples are 2001 double colon 0db8. Okay. 1234 1234 1234. Okay. Then I say 1230 6 colon 0000 colon 0000. So can you give the answers in the chat box? Apply rule number 1 and rule number 2 and give me the final answer. Yes. So Vaishnavi, you got the answer. So it is 2001 DB8. So all, and you can omit this 0. Okay. And all these can be replaced with a double colon and 1230, and this cannot be replaced with a double colon. Instead, you should use 0 colon 0. See, the answer, please use colon to represent. Benjamin, you have given the answer, but use a colon to represent it. Okay. So yes, Christian, your answer was correct. Okay. So only one time even though you have two continuous zeros, only one time you can replace it with double colon, right? Yes. So the answer is, yeah. So many are giving the answers. So I hope you understand the rule now. Janelle, you can again apply the second rule also. You have applied only the first rule. Apply the second rule and reduce it. So more examples of this kind is given in your course material. I want every one of you to solve it. Maybe 10 problems they have given in rule 1, 10 problems they have given in rule 2. So you can solve it to write your main exams, right? Now, what are the different types of IP version 6 address? There are unicast address, multicast address, and anycast address. So unicast address, you have a computer, okay, a client talking to a server. All right. So this is a client and this is a server. So it is one-to-one communication. That is called as a unicast communication. The next one is multicast communication. Multicast is nothing but you will have a single server which is sending the messages to many clients. Okay, so every clients will have will receive, or you will have a group where that group will be receiving the messages. Okay, so the multicast is used to send a single IPv6 packet to a multiple destination. So that is called multicast, to many. Okay, so you send it to many. Now anycast is one interesting addressing mechanism or address type that is specially present in IP version 6, which is not there in IP version 4. So anycast is nothing but you will have a client, okay, and you will have a server S1 having the IP version 6 address 1. All right, and again you will have a server S2. This will also have the same IP version 6 like that of S1. So this is one unique feature which is not present in IP version 4. We usually say that IP version 6 or IP address should be unique. But here you find out that S1, S2, everything is having a same IP address. So again, you have S3, again IP version 6, 1. The same IP address is assigned for S1, S2, and S3. Whenever the request is created by a client, the request is redirected to the nearest server. All right. So suppose imagine this is Paris and this is also Paris. All right. So if this client is in Paris, the request goes to the server 1, which is again very close to the client. Suppose you imagine this is New York. Okay. And the client has to move here. The client need not find out what will be the New York server's IP address. Simply he can send the request to the same IP address as when he was in Paris. Now the request again goes to the nearest New York server. So this is one very unique feature available in the IP version 6, and IP version 6 does not have a broadcast address. That is what you need to know, right? Then these are the types of addresses. Now prefix length. So what is this prefix length? Prefix length indicates the portion of an IP address which is allocated for the host portion and which is allocated for the network portion. So as I told you, URK 22CS mention your batch of students studying computer science, okay, in Karunya. Okay, the undergraduate students studying computer science in Karunya. And suppose it is 001, this uniquely identify that particular person. All right. So I can say that this is called as the interface ID and this is called as the network ID. Okay. So similarly here in IP version 6 also, you have a portion called the interface ID and you have a portion called the prefix ID. So usually by default, it is the prefix length can be 0 to 128. Okay. But you can have usually by default they'll have 64 bits as the prefix length. So how they'll write an IP version 6 address is 200 colon slash 64. Okay, so this is how they'll write an IP address. For example, you'll write 192.168.2.0 slash 24. So what is slash 24? 24 bits are for the network portion, okay, and the remaining 8 bits is for the host portion. Similarly here, slash 64 means 64 bits is for the network portion and the remaining 64 is for the host portion. So this is how the IP version 6 address is arranged. So there are many other IP addresses also available which is called global unicast, link local, loop back, unspecified, unique local, and embedded. So among this, in our portion, we are going to concentrate more on global unicast and the link local address. All right. So global unicast is nothing but it is like your public IP address. So it is routable in the internet. All right. It is a unique ID given to your device. So in the whole world, one IP address is given to you, especially for you, for your usage. That is called the global unicast address. And the link local address is, it is like a network address. It is like an address which is used within the network. So it will not cross the router. The link local address cannot move beyond the router. It is used for identification within your network. And loopback, again, it is similar to that of 127 series in IP version 4. It is like your for use for testing purposes. Okay. And again, unspecified address, the unspecified address is also like your 0.0.0 address of your IP version 4. And unique local, it is like your private IP addresses. And embedded IPv4 is used for communication between the IP version 4 and version 6 devices. Okay. So this is among which we are going to concentrate on the GUA, global unicast address, and link local address. So now in the coming slides, we are going to discuss what is global unicast address, how can you statically assign a global unicast address, can we dynamically get a global unicast address, or all those things we will be discussing. Right. And then, yeah, as I told you, this is a unique local address. The unique local address ranges from FC00. It starts from FC00 to FDFF. All right. So, as of now, your IP version 6 have they have started to assign only from 0 to 3. The first digit is 0 to 3. All right. That is what they have given. But this is a unique range given for the unique local address. All right. And now, global unicast address. Coming on to the concept of global unicast address. What are the components of a global unicast address? Is there are three components. One is the global routing prefix. All right. So it is like your network address. All right. It's like not like your network address. It is the global routing prefix. So that global routing prefix is given by the internet service providers. So internet service providers only can assign the global routing prefix. So as of now, I told you, currently available GUAs begins with decimal digit 2 or 3. Okay, so as you see here in these two cases, it starts from 2000 to 3FFFF. So after the global routing prefix, all right, global routing prefix, maybe your laptops will have address starting from 2000, okay, colon 1/64. All right, so this can be a valid IP address. All right. So now the global routing prefix, and next to that you have something called a subnet ID. So there is no need for the concept of subnetting in IP version 6, because IP version 6 is very enormous. 2 to the power of 128 is 34 undecillion, which they says that even every single sand of the land will get an IP address. That is what is the saying related to IP version 6. But now they are considering the subnet ID also. Okay, considering the future scope in future, if suppose they support subnetting, then the subnet ID is there. And again, the last one is the host ID. Okay, so like 192.168.1.0 is the network address, but 1.1 is the host address. So that 1.1 is the interface ID. All right, so the global unicast address has three sections, as I told you: global routing prefix, subnet ID, and the interface ID. All right. And the link local address. So why do we use a link local address? The link local address cannot be routed beyond the internet. Okay. So beyond the internet, the link local address cannot be used. It cannot be routed. All right. But every interface, okay, every IP version 6 interface are enabled with a link local address. Okay. So, and if the link local address is not manually configured, so statically you can configure a link local address. If you did not statically do that, the device will automatically create one for you. Okay, so how they create, we will see that. All right. So the range of link local address is always FE80. Okay, the link local address of a computer always starts with FE80. So now this link local address is used by two routers to share the routing messages. Okay, so they both can use this LLA address. So instead of using global unicast prefix address, global unicast address, they use this link local address to share the message between themselves. Or I can even use the link local address to share the message between the computers of the same network. Okay, so I can use this link local address. Now, how can I statically configure the GUA, global unicast address and link local addresses? So this is the command interface. You can go to the interface gigabit 0/0/0. Already we have done for IP version 4. So we used to do IP address, the address and the subnet mask for IP version 4, right? Here the command is IPv6 address, the address. All right, so this is an example of how you create. You have to give the prefix length also. How you assign an IP version 6 address to a router. All right, so this is one address. All right, so this is the configuration. The command is IPv6 address. So statically you can do this. Now, how can you statically assign to a Windows host system? So nowadays, all the computers, all your smartphones are coming with IP version 6 capability, right? So you can use the following IP address. You give the IP address. So what is the prefix length? You can give it, and the default gateway IP address. So in this way, if suppose it is a Windows host in your in your packet tracer or in your laptops, you can statically give an IP address in this way. All right, manually configure. The next one, how do you manually configure the link local address is by this way. So we know the link local address should start with FE80. So I give IP version address, FE80, the address, the link local address, and use the keyword link local. Now, I told you that if the link local address is not manually created, it is automatically dynamically generated. Okay, the link local address is dynamically generated. So why do we need a static configuration of link local address is to in order to easily remember it. Okay, it is in order to recognize and easily remember it, because what is generated by a computer, okay, what is generated by the auto mechanism may be a lengthier one. Okay, so but we are going to use it, we can easily remember. In order to remember it very easily, you can statically also configure the link local address, right? And dynamic addressing, so how do the dynamic addressing uses, right? So I want all of your attention here. So in dynamic, usually in IP version 4, okay, in IP version 4, the dynamic IP addressing is done by means of the DHCP server. All right, so all of you know that there are message communication called the DORA, discover, offer, request, and acknowledgement. Through that, any computer can get an IP version 4 address. Here in this IP version 6 scenario, similarly we have the DHCP version 6 server. Okay, you can maintain a DHCP version 6 server. Okay, but there are many options available. Okay, there are many options available. So what are the options? There are three methods available. One is Slack. Okay, I'll tell you what is Slack. Then Slack with DHCP server, and then only DHCP server. Okay, so there are three options available. One is the Slack, the other one is the Slack with DHCP server, and this only this DHCP server. These are the three options available. Now, what are those options? What are the information that you get from the maybe DHCP server, or here in IP version 6, even your router can help in the getting an IP address. Okay, your router can also assign an IP address. It can behave like a DHCP and help you in us getting the IP address. All right. So, what are those information given by the DHCP or dynamic addressing is, they give you the network prefix and the prefix length. They give you a default gateway. They give you a DNS domain name, a DNS address and domain name. So three methods: Slack with stateless DHCP server, and stateful, no, nothing else, only DHCP server. What all the information provided by them? Network prefix and prefix length, default gateway address, DNS address and domain name. And now, in order to get these information, there are two important messages transmitted. Number one is router solicitation and router advertisement. Okay. So what is router solicitation is, it is any device. Okay. As soon as I join a network, it can search for a router which can help the client to get an IP address. Okay. So that is called router solicitation. Router solicitation is nothing but a router search message. Okay. So now the after you solicitate, okay, then the router will respond and you can get an IP address. This can happen, number one. Number two is the router can also advertise. Okay, so they can advertise, they can send messages and inform the host on how they can get an IP version 6 address. They can even say these information can be given by the routers also. That is called router advertisement. Router solicitation is a message sent from the host device to the router. Router advertisement is routers can blow the trumpet and give the information related to the IP address. That is what is router advertisement. Now, we clearly understood what are the three methods, what are the messages exchanged, and what are the information shared in order to get the IP address. Now we will go to the process of those IP assignment. Okay. Number one is Slack. All right. So number one is Slack. So how do I get the information using the Slack? All right. So now Slack is the device automatically generates an address. Okay, automatically generates an address without the service of DHCP version 6. So DHCP protocol does not come into picture here. Okay, so it automatically it enable the device to do the address. Okay, to create that address. So what is that is, it obtain the necessary information through the router advertisement message. Okay, that is an IZMP version 6 protocol come into picture. So once a client is connected to the network, it receives router advertisement from the local router. Okay. So what is the local router will say is the prefix of the network. Okay. What is the prefix that is used? For example, the router will tell, come on, I'm just using 2001 DB8 ACAD colon 1 colon slash 64. Okay. So this is what the information transmitted from the router advertisement to the client. Now the client will generate the new IP address using two methods. One is EUI64 and the random generation method. Okay, there are two methods available, EUI64 method or the random generation method. So a part of an IP address is given through router advertisement. The remaining part of an IP address has to be generated through these two methods. So what are those methods? We will discuss shortly. Now the second one is Slack and the stateless DHCP. Now, even though you are using Slack, a little bit of information you are getting from the DHCP server. Okay. So what is that little bit of information? You are getting the Slack is used to create the global unicast address. Okay. The Slack is used to create the global unicast address. All right. And then the router will send the default gateway. Okay. Default gateway information. All right. And the DHCP server is giving other information like DNS server and the domain name. So a little bit of information it is getting, it is creating on its own. The global unicast address it is creating on its own. And the router is giving default gateway. Okay. It is giving some information, or it is giving information about DHCP server. Now, through that, it is getting the DNS information. Okay. So first the client is searching for a router. The router sends the prefix. Also, it is telling, see, I only have the prefix. For rest all information, you should contact DHCP server. Now, then this client contact the DHCP server and receives the information. This is called Slack and stateless DHCP. The next one, the method 3 is called stateful DHCP, in which first the client searches for the router. Okay, so it will go and ask the router, is there available any DHCP server available? Okay. Now he says yes. There it is like a discover message. It is like your DHCP discover message. It is asking any other DHCP server available. So now the router is sending yes. This is the DHCP server's address. Now he contacts the DHCP server, and the DHCP server gives all information related to the related to the IP address assignment. Okay, so you obtain GUA, you obtain DNS, domain name, and all necessary information you get it from DHCP version 6. These are the three methods. So Slack is everything you want for an IP configuration, you get it from the router. And Slack and stateful is a short information, that is a prefix alone, you get it from the router, and rest all you get it from the DHCP. And stateful is everything you get it from the DHCP, right? And then I told you, after getting the prefix, the IP address is generated, right? So using the EUI64 process or randomly generated process. So what is that EUI64 process is what we will discuss now. The EUI64 process is nothing but it takes your MAC address. So here you see it takes your MAC address, right? FC994775CEE0. So FC:99:47 is one part of your MAC address, and then the other part is 75CE and E0 is the next part of your MAC address. So in between this, it append something called FFFE. Okay, it append FFFE. All right. So that is appended in between. Now, and then the seventh bit of the client's MAC address is flipped. You see here, FE will become FC will become FE. All right. Now, this becomes a unique IP version 6 address. All right. This becomes a unique IP version 6 address. So this is how they generate. It takes the client's MAC address. All right. Clients take the client's MAC address, and then it has already received the prefix. Okay, so this is what the next four section 1 to 1, the next section 2, section 3, and section 4. Okay, so of your IP version 6 address. The remaining four section you will already get it from the router. All right, the router will give you the remaining four section. Only the second part of an IP address is EUI64 generated. Okay, EUI64 generated. Now randomly generated, again it generates the number in random. Now you may ask a question, ma'am, as it generates it in random, this is an example of randomly generated IP version 6 address. Now you may ask a question, ma'am, it is generating in random. What if they are equal? If any two IP address in the network is equal, so that is avoided by means of the duplicate address detection, which this process you will be learning in the coming modules. Okay, so it is similar to that of ARP in IP version 4. So there is a process called duplicate address detection, which tell you, yeah, there is a presence of duplicate address. So, and again, they reconfigure it. Okay. So this is how you get a dynamic IP address. You for the global unicast address. Okay, GUA. Now, dynamic addressing for LLA, again, the dynamic address for LLA is also similar to that of GUA. Okay, you get the prefix, and then using EUI64 and randomly generated 64 number, you generate it. Okay, so this is EUI64 generated ID. Okay, and this is random 64 generated interface ID. All right. And next, this is a address in the Cisco routers. Okay, so there are few commands. You can note it down. Show interface gigabits 0/0/0 will give you what is its hardware address. Now using the hardware address, it generates the IP version 6 link local address. So link local, how do you identify that it is a link local address? Because it has FE80. It is prefixed with FE80. It is a link local address. So even this command show IPv6 interface brief also can be used. Okay. Or you can even use show interface and show IPv6 interface brief. These are the commands which is used for configuration. Okay, so there are few packet tracer activities also available in your course material. You can do it. Next, moving on, we'll move to the next topic called IP version 6 multicast address. What about the multicast address? So there are two type of multicast address. One is well-known multicast address and solicited known multicast address. So multicast is something which can only be a destination address, because I'm telling to many. Okay, so all those will be all those belongs to a single group which will have one multicast address. Okay, Right. Now there are two well-known and solicited, and the well-known multicast address. There are two common multicast groups. That is FF02. If your IP version 6 starts with FF02, it is called all node multicast group. Okay. So in this group, every device, IP version 6 enabled devices can join. Okay. In the all node multicast group, every IP version 6 enabled devices can join. So the next one, FFE02 colon colon 2, all routers multicast group. So in this, all the routers will join. Okay, so every routers will join. Okay, and the command that helps to join a router in an IP version 6 router, the very important command that you should enable is IPv6 unicast routing. Okay, so you should give this command in the IP version 6 address. All right. So there are two common groups, all node and all router. Now, a solicited node IP version 6 address is nothing but it is similar to that of all node multicast address. Okay. And this is mapped. Okay. So this is mapped to that of a special Ethernet multicast address. A solicited node multicast address is mapped to that of the special Ethernet multicast address. So now even the node itself can filter whether that multicast message is not is for them or not. Okay, so the NIC itself will filter whether that particular IP version 6 packet is for itself or not. All right, so again there are practical exercises available. You can use your packet tracer to do it. The last topic for today is the subnetting an IP version 6 address. So now the question arises is, do we really need subnetting for IP version 6? As of now, it is no, but they have designed IP version 6 in such a way that the subnetting, they just have even subnetting in mind. All right. So as I told you, there is a network portion and there is a subnet portion and there is an interface portion in IP version 6. Now, this is an example of IP version 6 subnetting. So 2001 DB8 ACAD colon colon slash 64. So now what is the first subnet? 2 colon colon DB8 ACAD 000 colon colon slash 64. So you will have 64 unique IP addresses. Okay, 64 unique IP addresses. Again, it allows you to create around 65,536 slash 64 subnets. All right, so you must think of the size of the network. All right, now if I take 2001 DB8 ACAD, okay, colon colon 1 slash 64. This is one unique host IP address. Okay, that belongs to this subnet. Okay, that belongs to this subnet. Similarly, I can have 64 combinations. Slash 64 means here you have around 64 devices. So you can create 0000010002. So if suppose I want to write an IP address of this particular, it is 2001 DB8 ACAD colon 2 or 1 colon colon 1 slash 64. This is the next network. Okay, I'll show you with an example here. You see, this is how they have used this IP address. So they have just avoided this. Okay, so from 1. Okay, so this is the first subnet. I just give 2001 DB8 ACAD 1 colon colon slash 64. So now this device is 1 colon colon 10. Okay, this is 10. Similarly here 2 colon colon 10 and 4 colon colon 10 and 5 colon colon 10 and 3 is here. Okay, 3 colon colon 1 is this interface, 3 colon colon 2 is this interface, right? So we will be discussing practically the allocation of IP version 6, the routing of IP version 6 in the experiment number 10. All right. Now, yes. So how will you assign it? As we discussed, the command IP version 6 address is used. You can note down these commands which can be used for your practical classes. IP version 6 address, the command slash 64. So this is the next address, next interface. So a router has two interface, 0 slash 0 slash 0. Then you have 0 slash 0 slash 1. So 0 slash 0 slash 0 is 1 dot network. Okay, and 0/0/1 is 2 dot network. And again the next interface 0/1/0, it is 3 network, the next network. All right, so in this way the IP address is done. All right, so with this we have completed the IP version 6 module.